Hi everyone, this is Janine Co, aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly, and that's why we are extending our helping hand to you students to stay on top of your studies. And we are running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, we will be going over calculus and vectors. So we're just going to continue on from where we left off. Before we get started, I just wanted to make sure that you can hear me coming through and you can also see my screen. Okay, great. So here's the question. We have a manufacturing company finds that the profit for a production level of X motors per hour is P is equal to square root of 46x squared plus x cubed minus 43 for 0 to 24. So that's your interval. And you have to find the rate of change of profit when x is equal to a. So in this question, right, so the first thing you have to keep in mind is whenever you're given a function, so let's say you have p, right, p of x over here. So in that case, if you're looking for the rate of change, right, and because this is calculus, right, we need to find the first derivative, right, because the first derivative would give you the rate of change. And all you have to do is after you find the first derivative, you would just have to plug in a. Okay, let's go. So that means if you have p, right, when we're taking the first derivative, so p of x, so we know that based on the chain rule, right? So maybe I can just write p of x here. So this is square root of 46x squared plus x cubed, and this is minus 433. So we know that this thing over here, this is actually 46x squared plus x cubed, and this is raised to the power of 1/2, right? Because we know that this is in square root, therefore this is raised to the power of 1/2, and you have minus 433. So that means we can apply the chain rule, right? So what is the chain rule? So remember, the chain rule is basically you take your exponent, right? So this is 1/2, you bring that down, and then you multiply that to whatever is inside. So you have 46x squared plus x cubed, and then what happens here is instead of 1/2, you would have 1/2 minus 1, and therefore this would be negative 1/2. And we're not yet done because we need to find the derivative of your inner term, right? So you would have to multiply this to whatever the derivative of 46x squared plus x cubed is. So in this case, we apply the power rule, right? So you would have 46 times 2 because you're bringing down the exponent of 2. You're multiplying that to 46, so you would end up with 92, right? And as a result, your x would simply become just x, right? Because you're taking 2 minus 1, therefore this is just going to be 1. Plus, because this is 3, therefore you're going to bring that down, so you would have 3x, and this is squared, and that's it. So that's your first derivative. And because we need to find when x is equal to a, right, therefore we need to have to plug in, we need to plug in a, right, whenever there is an x, right? So maybe we can write this even better because this is raised to the power of negative 1/2, right? So let's say if you write this as 92, right? And this is x plus 3x squared, and this is over 2. And because we have a negative exponent, therefore that's going to be in your denominator for it to become positive. And this is 46x squared plus x cubed, right? Because this 1/2 represents, it's inside the root, right, of, well, specifically it's a square root. That's why I have square root of 46x squared plus x cubed. And because we want to change the variable from x is equal to a, right, therefore you're going to plug in p of a, right? And this is now going to be 92a plus 3a squared, and this is over 2 times 46a squared plus a cubed. So just make sure that this is also inside. Okay, there we go. So again, it really depends on your teacher, because some teachers, they like to simplify the terms, right? So in this case, because you have a radical in your denominator, some teachers, they don't like that at all. So you can actually simplify this further by multiplying your numerator and your denominator with 46a squared plus a cubed to actually get rid of your radical in your denominator. So this is a cubed, and this is over square root of 46a squared plus a cubed, right? So sometimes you can stop here, right, if that's what they're only looking for. But if you want to simplify this, then you would have 92a, and this is plus 3a squared. You multiply this to the square root of 46a squared plus a cubed, and this is now going to be over 2 times, because you're multiplying the radical to itself, therefore you're going to get rid of that radical. So you would have 46a squared plus a cubed. And that's it. Okay, great. So the next step is to find for what range of production levels is the profit increasing and what range is it decreasing, right? So from this I guess from this statement, right? That means if you have your first derivative, right, you would have to actually plug in, no, actually you would have to equate it equal to 0, because you want to find when the profit is increasing and the range is decreasing. So that means you're looking for when your function is increasing or decreasing. And in order for you to find when your function is increasing or decreasing, you actually plug in. Okay, no, you don't plug in anything. You take your first derivative, right, p of a, and then you equate that to 0. Simple as that. Because when you want to find your function, if it's increasing or decreasing, you look at your critical point when your first derivative is equal to 0. Great. Okay, so we have that. Now, because originally we had a here, right? So we can just keep this as x because this is what we wanted. So therefore, we're going to take this right here. So this is 92x plus 3x squared, and this is over 2 times square root of 46x squared plus x cubed. And we're equating that to 0, right? So I'm just literally taking this and I'm equating that to 0. Right? And then as you can see, when you multiply or you cross multiply 2 square root of 46x squared plus x cubed times 0, that's going to be 0, right? So you're going to have 92x plus 3x squared, and that's equal to 0. Does that make sense? And then when you pull out your x, right, that means you're going to have x over here and 92. Yeah, you can't really divide 92 and 3, so you can't really pull anything out. You can't factor 92 and 3, so therefore this is just going to be 92. And this is going to be plus 3x, right? Okay, great. Okay, so once we have that, right, so we know that our zeros would specifically be x is equal to 0, and let's see, we have 3x plus 92, that's equal to 0. Therefore, this is going to be 3x is equal to negative 92 divided by 3. So the other 0 would be negative 92 over 3, right? So when you're going to check where your function is increasing or decreasing, that means you need to assess where is it negative and where is it positive, right? So what I typically do, so it's really up to you the way you're going to find whether you're increasing or decreasing. So I like to sketch a parabola because I know that this is a parabola, right? So I'm going to plot my 0, and because you have a negative 92 over 3, so that would be first on your number line. So this is negative 92 over 3, and this is 0, right? Because I know that my parabola or my function is actually positive, right? That means my parabola needs to open upwards. And on top of that, you're only crossing, right? Because the multiplicity of each of them is actually just 1, right? So that would be opening upwards. Okay, so as you can see, in our parabola, right, if you have this over here, so from the left of negative 92 over 3, it's actually positive, and then between a negative 92 over 3 and 0, it's actually negative. And from 0 to infinity, right, so after 0, that's positive, right? So what does it mean when your function is increasing or decreasing, right? So you know that your range or your interval, right? So they're actually giving us a restriction. So it's 0 to 24, right? Can you guys see this? Okay, so this is your restriction. So because they're saying that you have to be in between 0 to 24, and that's based from here, right? So in that case, you need to just look at from here and onwards, right? So that means your function is increasing or your profit is increasing when you have 0 to 24. And that's true because if you look at 0, right, you actually change your sign, right? From negative, it becomes positive. Therefore, your profit, right, increases. So this means increases from 0 to 24. And that's the only information that we can take, or we can take here, because between, okay, so let's say if you're looking at when your profit is decreasing, right? So the only reason why I never really talked about this negative 92 over 3, it's because it's not part of your restriction. So you cannot really say that your profit is decreasing, although it is, because you're changing your sign, right, from positive to negative. This is decreasing, right? Your function is actually decreasing, but because your interval, they're telling you that it's between 0 to 24, right, with 24 included, you can only say that your profit is increasing between this interval. So you can't really say anything about the 0, which is negative 92 over 3. Okay, great. Okay, so we finish number 3 now, right? Again, if you guys have any questions, please feel free to reach out to me. And also, this session will be recorded, so you don't have to write things down. Just pay attention, take your calculator, punch in the numbers. Great. So for number 4, it says if y is equal to 2 minus 10u squared, and then you have u, which is equal to 2 plus x cubed, and x is equal to 5t squared minus 8t, you need to find y, and it's the first derivative of t at t is equal to 6, right? Okay, so here's the thing. You have y, right? And then you're using a variable u, right? So because this u uses another variable, which is x, and x uses another variable, which is t, right? So it's sort of like in between different variables, right? So all you have to do is make sure when you find the first derivative of y, right? So this is what you can do. You can find the first derivative of y first, right? And then just proceed from where you left off, right? So let's go and find the first derivative of y first, and then whatever we're getting, we're going to plug in u, right? We're going to plug in x, right? Because we're saying that u is equal to 2 plus x cubed. And then from there, once we have x cubed, we're just going to plug in t, and then we can find whatever this is, right? So let's find the first derivative of y. Okay, so from here, we can actually look at and apply quotient rule, right? Because this is f of x, right? And you have g of x. Does that make sense? So you have two different functions, right? And it's combined in a fraction. Therefore, you can actually use the quotient rule, which is 2 minus 10u squared, right? So again, what is the quotient rule? Just as a reminder, you're taking the first derivative, right? Or you're taking the derivative of your numerator times your denominator, which is 2 plus u cubed, and then you're subtracting that from the derivative of your denominator, which is 2 plus u cubed, times your numerator, which is 2 minus 10u squared, right? And that's going to be over your denominator squared, which is 2 plus u cubed, and you square that. So that's it. So from there, we can actually expand this, right? Because we still need to take the derivative of 2 minus 10u squared and 2 plus u cubed, and you take the derivative of that. So, okay, so we can just write that here. So the the derivative of this, right, is actually 0 because it's a constant. So 2 is a constant. So we're only focused on negative 10u squared. So negative 10 times 2, right, because remember we're applying the power rule. So negative 10 times 2, so that's negative 20. And this is going to be just u, right, because 2 minus 1, right, remember, after you bring down 2, right, when you multiply that to 10, that becomes negative 20 because of that negative sign as well. And remember, for your exponent, because you have to bring that down, therefore you're going to take your exponent and you're subtracting that from 1. So that's why it's negative 20u, and this is 2 plus u cubed. Then you have minus. Okay, so again, this is a constant too, right? Therefore, this is the derivative of a constant is 0. So you proceed with u cubed, right? So you take u cubed and you're bringing down the exponent, which is 3. So this is now going to be 3u squared, right? Because again, your exponent, you subtract that from 1, therefore you get 3u squared. And because you have a negative sign here, just make sure you have that. Then you multiply this to 2 minus 10u squared, and you're dividing this whole thing with 2 plus u cubed squared. Okay, great. So once we have that, we can actually combine everything, right? The reason why we wanted to combine everything is because we need to plug in our x and our t afterwards. Okay, so we can actually expand this, right, using by distribution. So you would have negative 20 times 2, so that's going to be negative 40u. So this is negative 40u, and you would have to multiply negative 20u times u cubed, which is actually negative, right, u raised to the power of 4. Okay, so from there, we can again distribute negative 3u squared with 2. So that would be negative 6u squared. And this is positive. Negative 3 times negative 10 would give you positive, and this is 30. And this is u raised to the power of 4, right? Okay, so we have that. And this is all over 2 plus u cubed. And this is raised to the power of 2. Right? So maybe we can actually combine the like terms. So we have negative 6u squared, and then you have minus 40u, and then this one would be, so we have negative 20u raised to the power of 4 plus 30u raised to the power of 4. That would be 10, right? So it's plus 10u raised to the power of 4. And this is over 2 plus u. This is cubed, and that's squared. Okay, so once we arrive at this answer, right? So we can't really simplify anything. I mean, you can factor out your u, but that's pretty much it. We can't really simplify anything. So now we're going to go ahead and figure out what we're supposed to plug in over here, right? Okay, so this is what you can do. So if you have your u over here, right? So they're saying maybe we can use a different color. So let's use purple for u. So for u, they're saying we have 2 plus x cubed, right? And they're saying you have t is equal to 6, right? So what you can do, you first take t is equal to 6, you plug that into your x, right? And then you're going to find what x is, and then afterwards you're going to find u based on whatever you're getting for x, right? Okay, so let's do that. So we know that t is equal to 6. So I'm going to scroll this up. Okay, so you have t is equal to 6. That's based from the given. And then you know that x is equal to 5t squared minus 8t. So you have x, which is equal to 5. Your t is 6 squared minus 8 times 6, right? So you're going to have, okay, let's see what this is. So 5 times 6 squared minus 8 times 6. So this is actually equal to 132, right? So you know that when t is 6, x is equal to 132. And then because you know that x is equal to 132, therefore you're going to go ahead and plug that into your u. So that means you're going to have u, which is equal to 2 plus, so x cubed, so that's 132, and you cube this. Okay, so maybe I can circle this just so we know what our variables are. So this is 2 plus 132, and you cube that. Okay, so now this is a huge number, which is 2. Let's see. Yeah, this is 2299970, right? So this is, yeah, okay. So we have 2,299,970, right? It's a huge number. Okay, so yeah, let me just double check. Yeah, okay. So that's our u, right? And guess what? We plug in this u into our equation over here, and we find what y first derivative of t is, right? Based on this. Okay, so oh, and also let's not forget, the reason why I'm doing this, right? It's because if you have, let's see, you're saying that you're looking for the y first derivative of t at t is equal to 6. Okay, so also, yeah, before I forget, I just wanted to talk about this first. Okay, so this is a different type of notation, right? This is just the y first derivative, right? But this is actually equal to, yeah, this is actually equal to dy over du, right? So this is the notation, and the reason for that is because we're taking the derivative with respect to u, right? So it's not exactly dy over dt, because what this question is looking for is you're looking for what's the derivative of y when it's with respect to t, right? So over here, right, you can't really just have this and then just plug in the u, right? Because you need to have it as dy over dt, right? So we're not going to plug that in first because we need to have dy over dt because we're deriving based on t, right? Not u. That's why you can't just plug in u. So this is what we're going to do. You know that you have dy over dt, right? And how would you arrive to dy over dt? Well, you're actually given dy over du, right? Which is based on this over here. And you're going to multiply this, right? Because you want to have dt in your denominator, therefore you're going to have du on top because you want to cancel out du, right? And then you're going to derive du with respect to dx, right? And why is it dx? Well, if you have dx in your numerator, you can cancel out dx and you're left with dt, right? So all of this, right? So you're deriving, right? So say for example, you're taking this u over here. When you derive this with, so this is actually du over dx, right? Which is over here, the second term, right? That means when you derive du over dx, that would be a constant. So the derivative of a constant is 0. And then you have 2. So this is 3x squared, right? So the derivative of u is actually 3x squared. And then the derivative of x is actually 10. 5 times 2, right? 10t. And this is minus 8, right? So, and also, just so you know, this is du over dx. So this is du over dx. And this is, okay, because we don't really have any space. Let me just move this. And this one is actually du. No, this is dx over dt, right? There. Reason why it's called du over dx is because you're deriving with respect to x, right? That's your variable. And you're deriving x based on t. That's why it's dx over dt, right? So once we have 3x squared and this, okay, so we're going to plug that in here. Okay, so we said du over dx is 3x squared, so that's going to be over here. And then this thing, dx over dt, is actually 10t minus 8, right? So this is 10t minus 8. And then you're multiplying this to whatever we're getting, right? So that's the time when you actually plug in your dy over du, right? So you're still going to plug this in, right? So you're still going to say this is -6, and then you have 2299, and this is 970, and this is squared minus 40 times, yeah, we're not going to have enough space, so let me move this here, and then this probably here. Okay, great. So we're just taking the u, right? So we're still using this, right? The t is equal to 6, x is equal to 132, u is equal to 2,299,970, right? We're still going to use that because we want to find what dy over du is, right? But it's just that that's not the final answer. So you have -40 times 2299, and you have 970, right? So -40 times u plus 10 u, so 2299, and this is 970 raised to the power of 4 over, this is now going to be 2 plus 2299, 970 cubed, and then you're squaring that, right? So when you plug this into your calculator, you should be getting about 1.890 times 10 to the -12, right? And then once you know that this is your, okay, this is dy over du, right? So once you know that this is dy over du, right, you're going to plug that in here, right? Because you know what the value is of dy over du. And then how would you find du over dx? Well, you know what x is, right? So you're going to take that value and you're plugging that in here, right? So we know that x is 132, you know that t is equal to 6, and you know that u is this, right? So we're taking this, right, dy over du is 1.890 times 10 to the -12. And for you to figure out what this is, all you have to do is plug in your x. So we said it was 132. And then you square that, right? And then your t is actually 6, right? So 10 times 6 minus 8, yeah. So that's going to give you dy over dt, right? So let's do that now. So this is 1.890 times 10 to the -12 times 3 times 132 squared. And you have times 10 times 6, and you have minus 8. So this is actually equal to, let's see, 1.8 times 10 to the -12, 3 times 132 squared. Yeah, this is multiplied to 52272. And then this thing, right, is actually 60 minus 8. So that's equal to 52, right? And all you have to do is multiply the whole thing. So that's going to be 1.890 times 10 to the -12 times 5,000, no, this is 52,272, and you're multiplying this to 52. Okay, so this is about 5.137 times 10 to the power of -6. Okay, so just keep in mind that you know how this is 10 times 6. When you type this into your calculator, just make sure that you have a bracket over here, because what would happen here is it's going to multiply this first, multiply this, and this would be left, right? So you're not really following BEDMAS or PEMDAS. So that's why just make sure that when you're looking for dx over dt, you just multiply 10 times 6 and minus 8 before you actually do this, right? Because you're not really following BEDMAS or PEMDAS, because you're actually multiplying that to the following terms, right? So this is your final answer. 5.137 times 10 to the -6. Great. Okay, so this was a long one, but hopefully you understand what we did. Okay, so just as a recap, we found what the derivative of y is, right? The first derivative. So that's with respect to u. That's why it's called dy over du, right? And then following that, we know that t is equal to 6, and how would we find x and how would we find u? It's based on t is equal to 6, right? All you have to do is plug in t is equal to 6 in your t when you're solving for x, right? And then following that, once you know what x is, which is equal to 132, you're taking 132 and you're plugging that into your u equation. So here, this is 132 cubed plus 2, that would give you u. And because you're getting this number for u, all you have to do is you plug that into your dy over du equation, right? And then you're going to get dy over du over here, right? And that's the value, which is 1.890 times 10 to the negative 12. But we're not yet done because we are looking for the first derivative of y with respect to t, right? Which is essentially dy over dt, right? Because what we have right now is just dy over du. That's not dy over dt, right? Therefore, in order to find what dy over dt is, we need to set up our own equation such that you have dy over du. You multiply that to du over dx, right? Because you want to get rid of your denominator du. And then the same thing applies for dx over dt, right? Because you want to get rid of dx in your denominator. Therefore, you're left with dy over dt. And then all you have to do is you find the derivative of u, right, which is 3x squared. Find the derivative of x, which is 10t minus 8. And you have to plug in your x and your t, right, in order to find what dy over dt is. And you're left with, or the result would be 5.137 times 10 to the negative 6. Okay, great. So hopefully that wasn't too bad. Let's move on to limits. So for limits, we're going to look at the end behavior now because this is as x approaches infinity and negative infinity. Or yeah, depending on the question, right? Okay, so whenever you're looking at limits and you want to know the end behavior such that x approaches infinity, I tell my students that you need to take out or you need to factor the highest power of x. So if you're looking at negative 8x squared, negative 8x raised to the power of 6 plus 7x raised to the power of 5 plus 65 raised to the power of 3, right? If it's x cubed, right? That means the highest power of x that you're seeing is x raised to the power of 6, right? You're going to factor that, and then you're going to be left with negative 8, and this is going to be plus. This is now going to be 7x raised to the power of 5 over, well, yeah, this is now going to be just 7 over x, right? Because what would happen here is if you multiply x raised to the power of 6 times 7 over x, right? What would happen to 6 and 1? That would result to 7x raised to the power of 5, right? Because you're taking, so this is exponent laws. You're taking 6 minus your denominator, right? Which is 1. Therefore, you have 5. That's why it's 7x raised to the power of 5. And then you have 65x cubed, right? So for 65x cubed, when you take that out, you should be left with plus 65 over x cubed, right? Because again, when you multiply this to this, you would just have x cubed on top, right? Because 6 minus 3 would give you 3, right? So that's it for this question. And then, yeah, so you have factored out x raised to the power of 6. Okay, so the reason why I'm asking you to do this is because anytime you're finding the limit of your end behavior as x approaches infinity, so that's what end behavior means or stands for, that means you need to remember to be able to factor out the highest power of x, right? And then from there, you're going to plug in infinity, right? So as you can see, when you computed for each of the limit, right? When you took out x raised to the power of 6, everything is going to be infinity, right? Because you know that the limit of this approaches 0, right? The limit of this approaches 0 as well, right? And why is it that the limit of this approaches 0, right? Remember limit laws, because you take the limit of this, right? You would have limit of negative 8 plus limit of this plus limit of this. So the reason why this approaches 0, because try this now in your calculator. If you have 7, right? And let's say your x would be, because it's approaching infinity, right? So maybe you can plug in 7 divided by 10,000, right? You're going to see that it's approaching 0 because it's 7 times 10 to the negative 4, which is 0.000, and so on and so forth, right? And on the other hand, yes, this is negative 8, but a number times infinity would still be infinity, right? That's why this would actually be negative infinity. And it's because of this negative sign over here. When you multiply that to infinity, that would give you negative and you have infinity. So that's how you find the limit of this. Okay, great. So for part B, right, same thing because you're looking at the end behavior, which is negative infinity. Now, the highest power of x here is still 6, right? So that means you're going to factor your x raised to the power of 6, and you're going to be left with 8 plus. Now this is 4, so that would be 8 over x raised to the power of 2. And this is going to be plus, and because this is 3, therefore this is going to be 6 over x cubed, right? So from there, you know that this approaches 0, right? The limit of this approaches 0 as well as this, right? And then you have 8, right, times negative infinity, right? So here's the thing, because this is raised to an even exponent, right? Okay, so think about this. If you have negative, let's say 3, right, you square this. Or even negative 3, you raise this to the power of 4. So whatever the result is of this, it's always going to be a positive number, right? Because any number, when you raise it to an even exponent, that would give you a positive number no matter what. So that's why if you're plugging in negative infinity over here, right, that means the result would still be positive infinity because it's raised to an even exponent, and on top of that, you're multiplying that to 8. So that's why this is positive infinity as opposed to negative infinity. Okay, so now we have a fraction, right? So we have negative 6 raised to the power of 5 plus x plus 6 raised to the power of plus 6 times x raised to the power of 3 divided by 6 times x raised to the power of 4 minus 8 times x, right? So over here, it's very similar. All we have to do is you factor out the highest power of x. So in your numerator, you can actually factor out x raised to the power of 5, right? So you're going to do this individually for your numerator and your denominator. So in your numerator, you have x raised to the power of 5. In your denominator, you have, well, the highest power of x is actually x raised to the power of 4, right? So in your numerator, going back, you would just have negative 6. And this is now going to be plus 6 over x squared, right? Because that would give you, so when you multiply this and this, that would give you 6x cubed, right? In your denominator, this is now going to be 6, and this is minus 8 over x cubed, right? So if it's 8 over x cubed, that would give you just x, right? Because 4, right, minus 3 would give you just one of your x's, which is in your numerator. Okay, there we go. So we have that. So we know that this approaches 0, right? This also approaches 0. So we're left with negative 6, right? And also, if you think about x raised to the power of 5 and x raised to the power of 4, you can actually subtract your exponents, right? So you would end up with just x, right, as a result. And you have the negative 6 here, and you still have the 6, right? So when you cancel this, you're going to be left with negative x, right? And guess what? Because you have negative here, and you have a negative infinity here, this would give you positive infinity. So that's how you find the limit for part C. So yeah, as you notice, this is looking at end behavior, so this is different from the limits we did from the previous classes, because from the previous classes we were just looking at the reg substitution and also just factoring out the numbers that can be factored, right? So okay, great. So for part D, we have 7x raised to the power of 7 minus 6x raised to the power of 4 divided by negative 8x raised to the power of 7 plus 8x raised to the power of 2. Great. So again, we're going to factor the highest power of x, so individually. So for our numerator, that would be x raised to the power of 7, and for your denominator, that would be x raised to the power of 7. Now for your numerator, when you take out x raised to the power of 7, that would give you 7 minus, this is now 6 over x cubed, right? And in your denominator, you would have negative 8, and this is plus. Now this is going to be 8 over x raised to the power of 5, right? Okay, you can cancel this out, and you can also cancel this out. This limit approaches 0. This limit approaches 0 as well. So you're going to be left with 7 over negative 8. So that's your limit. So for part E, yes, same thing. We're going to take out or factor the highest power of x. So in our numerator, that would be x raised to the power of 4, right? And in our denominator, that would be x raised to the power of 5, right? So going back to our numerator, when you're taking out or factoring x raised to the power of 4, that would be negative 6, and this is over x, and then this is plus 6, right? Then in your denominator, this is going to be x raised to the power of 5 times negative 7 over x cubed, and this is plus 6, right? Okay, great. So once we have that, we know that this approaches 0, right? This also approaches 0. And we can actually say that this is going to be 1 over x now, right? So don't forget, you still have the 6, right? So this is going to be, let's see, 1 over x. And, okay, so we have 0 and 0. Then you multiply this to, so this is 0 plus 6, which is going to give us just 6, right? So it's 6 over 6, right? Essentially, this is going to be, and also this is 6 right here because you're taking out 5. So that means you can just cancel this, right? So you're left with 1 over x. So when you have 1 over x, right? And because if you have 1 over infinity, right? So when I say 1 over infinity, when you try to plug in your calculator, 1 divided by, could be any number. It could be like, let's say 9,000, right? That would give you 0, right? So it's not exactly 0, but it's 0.00 something, right? So it's actually approaching 0. So any number, right, over x when it's infinity, that would approach 0. Yeah, you can even try like 15,000, right? You're going to get 0.000 something. So that's still approaching 0. Okay, so for part F, we have limit. Yeah, so we're just going to factor out the highest power of x. So in this case, it would be x cubed. But hold on, because they're saying their x now is x approaches negative 3. So yeah, you have to be careful. So I know this is pretty common to students. I think because you have this assumption that all the questions that you've been doing, their x approaches infinity, x approaches negative infinity until you get to the last question, which is as x approaches negative 3. So you have to read the question. So that's why I put that in there because I want to make sure you guys know what you're doing. So you're not going to take out x, right? So all you have to do is you plug in negative 3, right? And see whether you have an indeterminate form. So if you have an indeterminate form, then you need to do something about it. Okay, so you have negative 6, right? And this is going to be negative 3 cubed minus 6 times negative 3 squared. So this is just direct substitution, right? You're not going to factor the highest power of x. And you have negative 6 times, this is negative 3 raised to the power of 4 plus 6 times negative 3, and this is squared. Okay, so this is what you do first, right? Because first of all, you don't really know if this is indeterminate because you haven't really factored it. But let's check your denominator first, because anytime your denominator is undefined, right? That means there's going to be a problem when you're finding the limit, right? So maybe plug this in. So if you have negative 6, so I'm just punching in the numbers in my calculator for my denominator. So this is negative 6 times negative 3 raised to the power of 4 plus 6 times negative 3 squared, right? So your denominator is actually negative 432, right? Which is fine, right? But what about your numerator, right? So you have to calculate this individually for you to find whether you're getting 0 over 0 or infinity over infinity, which are indeterminate forms. So for your numerator, you have negative 6 times negative 3, and this is cube, minus 6 times negative 3 squared, right? So your numerator is actually 108, which is fine, right? It's not really causing any indeterminate forms. Therefore, when you divide this, right, 108 divided by negative 432, you should be getting negative 1 over 4, right? So yeah, that's your final answer. So yeah, pay attention. It doesn't mean that you're looking at the end behavior. And then the last question was a trick question. Okay, great. So that's negative 1 over 4. And for the next question, we need to find the inflection points for f of x, which is equal to this polynomial. Okay, so first of all, what are inflection points? So basically, inflection points are in calculus, right? So based on advanced functions, we know what inflection points are now. But when we're talking about calculus, right, we're looking for the second derivative and we're looking at the critical value when the second derivative is equal to 0, right? So that's what inflection points are in terms of calculus, right? So this is what we're going to do. Let's find the first derivative first and let's find the second derivative. So, and also just to remind ourselves, right, inflection points are just the change in concave and convex, basically. So it's something like this. So you're not just crossing your x-axis, you're crossing and at the same time you're changing the concavity. So this is basically here. This is concaving down and now it's concaving up, right? So first of all, what's concaving down? Just as a recap, this is concaving down. Concaving up is this, right? Okay. Yeah, we're gonna go to curve sketching in a bit, so, but not in this class, yeah. But we're going to do a review. So the first derivative of x, right? Again, we're just going to apply the power rule, right? So this is 24x cubed. Yeah, nothing new. So this is minus, okay, 21 times 3 should be 63, right? X squared. And this is minus 67 times 2. So that's minus 134x. And this is plus 6, right? And then since we found what the first derivative is, right, we're supposed to find the second derivative, right? So second derivative, again, we're going to apply the power rule. So 24 times 3. So that's equal to 72x squared minus 63 times 2. So this is 126x, and you have minus 134, right? So that's the second derivative. And guess what? Because it's inflection point that you're looking for, you need to equate this to 0, right? So 72x squared minus 126x minus 134, that should be equal to 0, and you're going to apply the quadratic formula. But before that, right off the bat, I can actually divide everything with 2, right? Because I know that I can simplify this. So 72 divided by 2 should be 36. Yeah, it's 36. And let's see. 36, and then you have 126 divided by 2, which is equal to negative 63x. And don't forget our x squared, right? And this is minus 63x. Then you have 134 divided by 2, which is negative 67. Okay, so once we have that, we're ready to use the quadratic formula. So our a is 36, right? B is 63, or negative 63 rather, and then your C is negative 67. Okay, so here's a quadratic formula. It's negative b plus or minus b squared minus 4ac over 2a, right? And our negative b, which is negative 63 plus or minus b squared, is negative 63 squared minus 4 times 36. That's our a. Our c is negative 67, and that's going to be over 2 times 36, right? So when you simplify the 63, this is now positive 63 plus or minus. Okay, so here's the thing. When you try to plug this into your calculator, the square root, right? Like literally square root of negative 63 squared plus minus 4 times 36 times negative 67, you're going to get a decimal number. So you don't really want that because you're in grade 12 now, you're in calculus. So you want to make sure that your final answer is expressed in a radical. So that means you have to do this manually. So you're going to just plug it into your calculator. So you're going to take just negative 63, you square that, and you have negative 4 times 36 times negative 67, right? So you're going to get, so inside, right, I'm just plugging in this in my calculator without the square root. I'm getting 13,617, right? Yeah, this is way too long. Okay. And this is going to be over, so 2 times 36, that's 72. Yeah, so that's it. And because you're looking at, a quadratic formula, so your x, there's two of them, right? There's the plus and the minus one. So if you have plus versus minus, right? So now this is the time that you're allowed to express your final answer in terms of decimal. So try this. You have 63 plus square root of 13,617 divided by 72. So your x value should be 2.5, and then if it's negative, right, so you're going to have 63 minus square root of 13,617 divided by 72. This would be negative 0.75, right? So that's your x over there, right? And because it's an inflection point, right? So your inflection point could be at 2.5 and negative 0.5, right? So you have IP at 2.5, right? Comma, whatever this is, right? So how do you find your y coordinate? Well, this 2.5, all you have to do is plug that into your function. So your function is this, right? 6x4, so let's say we plug in 2.5. So 6x4 minus 21, yeah, we were supposed to plug in 2.5, right? 2.5 raised to the power of 4 minus 21 times 2.5, then you have cube minus 67 times 2.5 squared plus 6 times 2.5, right? So let's see what this is. Yeah, I'm just punching this into my calculator. Then you have 21 times 2.5 cube minus 67 times 2.5 squared plus 6 times 2.5. Yeah, so you should get negative 497.5. Great. So now we know what this is. So this is now negative 497.5. Okay, so let's see what negative 0.75 gives us. So f of negative 0.75, right, that's equal to, okay, 6 times negative 0. I should have started here, right? 6 times negative 0.75 raised to the power of 4 minus 21 times negative 0.75 raised to the power of 3 minus 67 times negative 0.75 squared plus 6 times negative 0.75. That's it. Okay. Okay, so punching into my calculator these numbers, so you have 6 times negative 0.75 raised to the power of 4 minus 21 times negative 0.75 cube, right? And that's minus 67 times negative 0.75, and you're squaring that, plus 6 times negative 0.75. Yeah, so this is actually negative 31.4. So we know what this is, right? And because we don't really have any restriction, right? So we can say your IP, so you have two inflection points, which is at 2.5 comma negative 497.5 and negative 0.75 comma negative 31.4. So just to clarify, this is when you have f of 2.5, right? So you're probably wondering, maybe if you're studying, you forget, where would you plug in the 2.5? You're plugging that into your function and not your second derivative. Because otherwise, if you plug this into your second derivative, then that means that would give you 0, right? Which is not really going to do anything. Okay, great. So, yeah, let's move on to the other sheet. Yeah, this is the last question, so. Okay, let's go and find that. And by the way, because we've gone through this, right, so that means I'm just going to move on to, let's see. Okay, so because there's only 5 minutes left, right? Because I just realized the first question for the next live stream, supposedly, it's actually longer, so I don't think we're gonna be able to finish that in 5 minutes. So let's just end this class and then I'll see you on Monday then. Yeah, because yeah, it's going to take a while. It's not just we can finish that in 5 minutes. So let's see. Okay, great. So yeah, we only have like 4 minutes left now, so there's no way we can actually do another question because the next question will be to find, let's see, what's the next question? Yeah, we need to find the second derivative and we need to simplify that. So yeah, we cannot do that in 4 minutes. So yeah, I just wanted to say again, thank you so much for, just attending my classes. I think it just means a lot for you to sit there, look at your screen, and learn math with me. I know that this is a very difficult time, like just being at home. It's probably driving you nuts now. So yeah, thank you so much guys for coming in. And if you do have any friends, who wants to stay productive and also keep on top of your studies, just ask them to join, right? Because I think at the end of the day, the more the merrier. So yeah, thank you so much. And I'll see you on Monday for our next calculus class. Bye guys.